Hello, everyone.
Hey, everyone.
So I still have some people waiting in the entrance. So let us quickly introduce you. So my name is Artur Rodrigues. I've been with AWS for almost 3 years. And then I'm a public solution architect. So which means I have been talking to like hundreds of customers from public sector, from like West Coast to the East Coast. And it turns out that microservices is one of the recurrent topics in my conversations with my customers. And then something that the account team can help you if you are more interested in exploring microservices. You should talk to your account team, like a solution architect, to do like workshops, whiteboarding, so you can better understand how microservices can address your specific business use case.
Hey, everyone. I'm Dave Liggat, so I'm a colleague of Arthur's. I work out of Vancouver. I've been with Amazon for 2.5 years, and I work in our professional services consulting practice. And so any of the topics that we discussed today, if this would be of value to your organization or the mission that it serves, we do lots of projects with customers all across Canada, and we'd be more than happy to have a conversation and see if there's some way that we could help. So great to meet you all.
All right. So citizens expect innovation. And then why they expect innovation? So typically, when I look at my kids, I have a 16-year-old and an 11-year-old, and then recently, I took them to open up a bank account. And then it really surprised me when my 11-year-old came to me with his cell phone on his hand, say, "Dad, that's my bank account. I can check online. I can do all my transactions using my cell phone." And then he figured it out by himself. So that new generation expects that everything can be done through their cell phones. So innovation really drives us to give that user experience to our citizens, to any customers that we have. But sometimes innovation does not come in the shape as like a mobile application or a fancy web app that you deploy to your customers. So I'd like to share a story when I was working for a healthcare. I worked for healthcare for 3 years. And then we had an interesting challenge. So when I was working for healthcare, we had 7 health authorities. And those health authorities were forced to have a shared services. So then IT was one of the shared services that we offered to the 7 health authorities. I don't know how many of you have already tried to do user consolidation, but it's quite traumatic. So then we decided to not do any user consolidation. We decided to create a framework where you could detect or identify how many accounts a person would have. And why we need to address this challenge. Imagine a doctor going to a hospital and then he has to remember several passwords to log in to get his work done. Similarly for a nurse. So these are our customers as well. So we have worked in a data processing, collecting all the data from 7 identity sources, trying to find a pattern that would tell us how many accounts a person would have. And that took us a while to understand. So that goes in that circle of innovation. So we experiment, we got some feedback, new ideas, and then you try all over again. But the caveat, though, was doing that on-prem was quite difficult. Every time I needed to require a server, it took me like a week. Every time it requires me to, okay, I need a new database for testing. Oh, that's not possible for you. So even innovation sometimes inside the organization, on-prem takes some longer cycles. And then, okay, we successfully delivered the solution. I was quite proud of the results we got. And then everyone who saw the solution being delivered came talking to us, say, "Hey, you know what? That solution is amazing. Why don't you add this new feature? I think that all happens to you. So why don't you tweak this module to add something else?" But it turns out it's not that simple, especially because the way I have developed the application was based in a monolith application, which typically ties to one database. So that has to do with some of the topics we're going to be talking today. But let's talk about how some companies, some public sector companies, successfully deployed some solutions. So I have 3 customers to talk about. The first one is the Ottawa Hospital Research, who released an application called Can Immunize. So their goal was to address vaccine hesitancy. So what is vaccine hesitancy? So one of the things I noticed recently, like in the news, that old-time diseases are coming back, right? Because people are afraid of taking vaccines, or may sometimes have misinformation about vaccines. So by having a mobile application, a free mobile application, bilingual, that I can get all the information directly from the source of my hospital, which I trust, it's much easier for me as a citizen, because I don't have to go to the internet and get all those like fake news about any topic I go to the internet. So just getting directly from the source. And something else that I like about the application, it helps the parents, it would be in my case, to remember when you have to take your kids to be vaccinated. So when I was with my kids, all I had was a paper, and then I have to figure out some mechanism to remind myself when and where I have to take my kids to be vaccinated. With this application, this mobile application, they are addressing all of that. So I really like that solution. The second solution is the Evo car share. So in Vancouver, we don't have Uber. I think that might be a surprise for some of you. And then because we don't have Uber, I really like to use Evo car share myself. So Evo is a one-way car sharing offering. They have roughly 1,500 cars around Vancouver. And the way it works, I will walk into a car, drive to the location I want to go to, and then drop the car in that location. I don't have to pay for parking, I don't have to pay for gas, anything else. Just go drive and pay for whatever I have utilized, just like cloud, right? You just pay for whatever utilized. So, but one of the challenges they had was, how can I do relocation? And why do I have to relocate cars? Because whenever I drop a car in a place, that place might be a place that people most likely won't go to pick their car up again. So they have a likelihood, the chances to be realized. So they came back to AWS asking, can you help us create a model, a machine learning model, to predict how I can relocate my cars to places that the likelihood to get this car picked up, to places that have more likelihood for them to be picked up. And then we helped them. It was quite a project. Actually, I worked in this project with Dave as well. And then I'm glad to see that it was quite happy. And then there's a web post on our website about the use case. And lastly, BC Hydro. So BC Hydro is the 3rd largest Canadian electricity utility in Canada. They serve approximately 2 million people throughout British Columbia. And then one of the things they had to run a model every day. And that model was being running on-prem. And it was taking them 10 to 20 hours. And they soon realized that in a short period of time, 20 hours will become 24 hours. Then they wouldn't have a day to run that daily model. So they contact one of our partners, Onica, to help them to move that modeling to the cloud. So Onica helped them to move this workload to the cloud. Then they could use the elasticity. So they're now using 216 CPUs, and they reduced it down the time from 20 hours to 10, 15 minutes. And they also realized that the amount of money they're spending in the cloud is not what they thought, because we charge you by the second. So if you run 10 minutes of 216 CPUs, it's only for 10 minutes of time. So I really like those use cases. But how can we get there? So what changes have to be made for us to be agile? Because that's the new world. We need to be agile. And then talking to our customers, we identified 3 common patterns that these customers have changed in a way to be more agile. And they are changing their architectural patterns, changing the operational model and how they deliver their software. And then we're going to be touching in all these 3 points here with you today. First of all, we have 2 types of applications. We have the monolith, what some people call also classic applications, and microservices. So a monolith, I think it came on the right time. Okay, I have developed a lot of monolith applications as a developer because that was the only way we knew how to develop software, let's face it, okay? We were influenced by companies who were developing operating systems, which has to be tightly coupled. Latency was a concern. And then the business cases that we had back there wasn't the same that we have today. So when a monolith was developed, that was actually all we know about it. But then society evolved. Technology evolved along with it. And then now we have different tool sets that help us to create new type of software, which it is a microservices type of software. Why microservices matter? So imagine I have a monolith application, has like three-tier applications, web, database, maybe a middle tier. Then now I have to scale. Instead of serving hundreds of users, I have to serve millions of users. I have to scale my entire application with it. Sometimes it's not worth it. It costs too much. What if I need to add a new feature, as was mentioned to you before? So I had a system that was doing data modeling for all my identity providers. So what if I need to add something else? So probably, and chances are, I'm going to deliver a new application. And that's why I'm seeing some institutions having several mini applications, because we developed any applications for new features that their application can no longer absorb or create. So the response is to create new applications. With microservices, I have several components, and each component does something well. And something that I really like about microservices is the microservices is a polyglot. You know what I mean by microservices being a polyglot? Imagine that your entire team only develops in C#. But it turns out that one library for a specific task, let's say machine learning task, we have the best library in Python. You know what? With microservices, I would be able to write one module in Python and everything else in C# if I want to. And the reason is because it's isolated. Microservices are isolated, and then can do just one thing well in that specific component. What looks like a microservices architecture? So I can tell you it does not like quite what you see in the slide today. This is a simplistic view. What is a microservices, okay? But we still have our customers that interact with us through API calls, web applications, even have IoT devices sending data to your application. Once it gets to the API and web server, sends the requests to the microservices. And then microservices just process your information. What I like about this diagram, you can see I have multiple databases. So I no longer have a restriction to connect to one single database, when the restriction that typically I have in a monolith. Something else that I like about microservices, it scales only what needs to be scaled. Let's say my account lookup now has lots of requests. My account lookup can scale automatically, and in all my other microservices, it stays the same. So it's smart enough, and then cost-wise, it makes sense. And I can also have microservices talking to microservices, as you can see in the diagram, account lookup talking to my shipment query. I can also define policies within my microservices, which microservices can talk to what microservices, in a way that I can make it secure. And why customers love AWS to deploy microservices? So my favorite benefit by running microservices on AWS is the integration. I think I could spend hours talk about how the integration that we have with our services benefits you. So it's not only having a VPC networking for you to run your microservices on top, having identity access management, load balancing, auto scaling. You also have logs, machine learning, serverless, everything else that you can use to make you successful running your application. And then typically, when you're using microservices, they are associated with DevOps, because that's how the agile methodology sometimes asks you to deploy your software. And then you have the tool set for you to deploy microservices using the DevOps approach. And then I'm going to touch in that in more detail. And finally, security. On AWS, security is job zero. We have several international recognized security certifications, along with the industry certifications as well. We have specific topics about security, but we think about security every day and every second. Okay, how can I develop and deploy code in a microservices architecture? But before I answer that question, let's make a contrast here. Let's think about how a monolith or a traditional development life cycle occurs. We have all the developers, okay? They can be siloed. They can be maybe working different components of your application. But one thing always is true about a monolith development. All the components are intertwined in such a way that if I change something in one component, you're probably going to affect another component that I had no idea was accessing my APIs. And I've seen happening, all the time. And then when you deploy your code, you have to deploy them all together. You just bundle all the bugs and new features, everything that you need to deploy to production into one pipeline. That's the build, test, release, and monitoring. So that happens in one shot. What if something goes wrong? So you have to roll out your application and then back to planning and try to identify what went wrong. And then when you try to identify what went wrong, that's what happened. That's when something happens that really, really bugs me, and I think it bugs some of you too, as well, is that when you get that stamp from your developer. He goes back to you and say, it works in my machine. So I have no idea why it failed in production, but it's working in my machine. I'm safe, right? So what you do? So that has been a constant headache in several ITs. It works on my machine 100% certified. And the reason it fails is because maybe he's using a different library. Maybe he's decided to use a new component that is not yet deployed in production. Or maybe he does not have access to the components that other teams have changed, and he still uses an old library from the teams from the same application. So different reasons. I've encountered once in one of my customers, they were developing an application that requires changes on the database schema, and then the developer haven't developed in a way that it would change the database. So all those nuances of developing software come into play when you deploy in a monolith application. So that's why we now have microservices to help us to be not only more agile, but to help us to address issues like works 100% on my machine.
Cool. Thanks, Artur. So as an ex-developer, I have a lot of painful personal experience in this area. You have these large, complicated applications. They're built by large teams, each working on separate components. And they're being deployed in rather different environments. You have developer desktops, you have maybe test farms, pre-prod environments, production, maybe a mix of cloud and on-prem. It's very difficult to ensure you have consistency between all of these environments and therefore a lower risk of any new deployment or any new change. So to address this problem, we're going to talk through a few sort of technical solutions here. Definitely something that addresses this problem in quite an elegant way is the use of technology called Docker containers. So this was popularized a few years ago. And if you've never used containers, you can really think of them as essentially lightweight virtual machines. So traditional virtual machines, they're quite large in size. They have a full operating system. They tend to be long-lived. They'll receive software patches and be multi-gigabytes in size. Containers, by contrast, are quite small. They can be, really as little as tens of megabytes, or hundreds of megabytes is more typical, but they're much smaller. So you don't have the full operating system image, but you have all the code for an application as well as its dependencies. And it's possible to take an existing or a new application, turn it into a container, and you have a container image that'll run identically across any of those environments that I mentioned. So it can run on a desktop, or it can run in an on-prem data center somewhere. It can run in the cloud, and it's the identical software image. With cryptographic authenticity that it's the same image being run in all places. And this is one of these tools that gives us confidence to move away from monoliths and towards microservices. We can afford to be more agile. Deployments can be much lower risk because we know, with certainty that the same code is being run in all places. So we obviously have a very vast suite of offerings for how to deploy your applications, and we have a few services that are uniquely targeted at containers and are very popular among our customer base. So there's three that I'll touch on briefly. We have ECS, which is our native, highly AWS integrated container offering. It's natively integrated with identity and access management, with CloudWatch logs. It's a great, if you're a customer that's already a heavy user of AWS, it's a great choice because it uses a lot of the same primitive pieces, and it runs, on top of EC2, our virtual machine service. We also have EKS. So many customers like to use Kubernetes, and EKS is a managed form of Kubernetes that runs in AWS. And then finally, we have Fargate, which is a serverless container offering. I'll speak more about that in a few more slides. But regardless of which method you take, containers are a very good choice for the deployment of your application on AWS, and you have some flexibility as to the right deployment model. So with that in mind, I'd like you to contrast this picture with the one from Arthur's slide. So in Arthur's slide, we really had a coordination problem. We had a large set of developers that were all feeding into the identical monolithic code base. In this case, we've broken up that monolith, and we have separate developers all focused on shipping a separate service. Now, these services needn't have the same delivery pipeline. They're all going to need some notion of build and test and release and monitor. But those needn't be on the same cadence. We might well imagine that some of our foundational infrastructure, perhaps around identity, is less likely to change than maybe some of our more experimental features. And so there's no reason to really couple those delivery pipelines together. It makes sense to let the services be true to themselves as far as what makes sense, from a delivery standpoint. Also, as Artur mentioned, I'm sorry, I lost my train of thought there. Yeah, sorry, my mistake. Let me just quickly move on to the next slide. Oh, my apologies. As Artur was saying, we've seen this pattern, in the industry before. Amazon Retail actually went through a very similar process. So in the early 2000s, Amazon Retail had been shipping a monolith application. And much of the functions that we expect of the Amazon website, shipping and payments and inventory management, were all being combined into a single application. And so Amazon Retail went through the process of splitting that up and having separate smaller teams own the separate units of functionality. And that's very much the way that both Amazon Retail and AWS delivers software today to its stakeholders. Okay, so you may look at that prior slide and see, lots of building, lots of testing going on, and you might, sort of reasonably ask, isn't this a lot of additional infrastructure for an already overburdened IT department to manage? And so we don't really view it that way internally. We have a number of services that exist to really take away that maintenance burden and allow developers who are working on their microservices to be tightly focused on their business objective and less so on kind of the undifferentiated heavy lifting of supporting infrastructure. So there's an acronym that you'll run into in the industry, CI/CD, and it stands for continuous integration, continuous deployment. And there's sort of varying takes on this, but ultimately it comes down to the idea that the life cycle of a piece of code, when it's checked in from a developer, should be automated all the way through review, build, test, deploy, and eventually monitoring. And we have a number of tools that are really targeted at this use case for each one of these individual steps. Many of them, in fact, were built internally for Amazon internal purposes, and then were productized when we saw how useful they were within the company itself. So if I can take you briefly through kind of the life cycle of a piece of code, we'd have a developer likely working with a Git repository, and they would commit source. They would probably want a peer to do some peer review, so they can use AWS Code Commit to manage that repository and also manage merging of branches and requests and feedback and so on. When that's checked into Code Commit, that can automatically kick off an AWS code build job. So this is a build service. It's completely language agnostic, so whether you're working on C# apps or Java or Python, whatever the case may be, Code Build is able to take that source and produce a software artifact out of it. And this is totally serverless. It's serverless, pay as you go. There's nothing to patch, nothing to maintain. You're simply paying for the compute time for the duration of a build, which in a great many of circumstances is quite a small duration. Also within Code Build, we can run tests. So that might be unit tests, or it might be sort of larger scale integration tests. But whatever the case may be, Code Build can run those tests, and it can report back to the developers and reviewers whether or not this was a successful test execution. Assuming all that went well, we can then deploy code within these CI/CD tools. We have AWS Code Deploy for deploying onto virtual machines or containers even, or Lambda functions, which we'll talk about shortly. And we have AWS CloudFormation that can create new AWS resources on an automated basis in response to the deployment. Finally, monitoring. So we have a pretty rich suite of solutions around monitoring. We have AWS CloudWatch, which has several components within itself. We have CloudWatch logs, so you can take all of your application logs, for example, send them all to CloudWatch logs. You can even react to the presence of certain log messages. So if you're looking for a particular error code or a particular condition that's arisen in your application, you can kick off an automated process just by processing CloudWatch logs. Same is true of CloudWatch metrics, so things like CPU, disk, memory, even custom metrics that are important to your particular application. Maybe there's some custom metric you can compute. You can publish that to CloudWatch metrics and take action based on those metric values. And then finally, AWS X-Ray. So this is a tracing service. You can sample and trace through individual requests and identify sources of latency that may exist over a large user base. There's a certain percentile of requests are slow. AWS X-Ray will help you identify those. So the reason we highlight all of these services is just to make it clear that you're not starting from scratch when you're developing these microservice architectures. There's a lot of sort of useful pieces you can put together that allow you to focus really solely on your business logic and less so on let's set up yet another test server, yet another build server. You can really focus on the actual problem you're trying to solve for your stakeholders. Now, you might reasonably say, though, isn't this very hard now that we have lots of pieces to operate? It is, in some sense, a more complex system. And I'd like to draw an analogy to address this point. Suppose your team was tasked with crossing a river. Now, the requirements are vague, as they often are in the world of software. Requirements are vague, but you've been asked to cross a river. And you don't know the frequency, you don't know the nature of the cargo, the split between, say, human passengers and maybe animal passengers or maybe cargo. There's some split in some sense, but you still have to cross the river. So there's two ways to solve this problem. One would be to acquire and operate a cruise ship. Now that is a simple system in the sense that it's a single boat, but obviously there's massive operational overhead with running a cruise ship, and it may not be super suited to the purpose. Maybe if it's mostly freight, a cruise ship probably doesn't make sense. If it's not necessarily tourists, but it's instead military personnel, a cruise ship would also likely be questionable. So that's one way to solve the problem. The other way would be to employ a fleet of smaller, more custom-built boats that you would acquire and sort of scale, if you like, on an on-demand basis as it became clear what the actual shape and dimensions of the problem were. So you might employ a small fleet of passenger ferries, maybe some barges, maybe even some kayaks, and you end up with what seems like a more complicated system to solve the problem, but in actual fact, you're solving the problem in a more fundamental, elegant way. And that's very much how we think of kind of monoliths versus microservices. Like I said, though, you shouldn't assume that you're bringing on a large maintenance burden for additional infrastructure. So this is a slide showing the breakdown of our compute services. We have a number of compute offerings. I hope it's visible at the back, but I'll read them out. This is a breakdown of our compute offerings. And so right down at the bottom there, we have EC2. So EC2 is fairly classic virtual machines, the closest analog to what you would have on-prem. Now we do have a very rich set of instance types. Some are general purpose, compute optimized. Some are very specific to specific use cases, having GPUs attached, for example. But with all of our services, there's some split between what does AWS manage and what does the customer manage. In all cases, AWS manages hardware, software networking, facilities, that sort of thing. But with EC2, that's where AWS's involvement tends to end. And so for things like software patching, that's a responsibility the customer would be assuming. So EC2 is a great fit for large, complicated legacy applications that may not be suitable for more novel architectures like containers. EC2 is a perfectly reasonable fit, but it's not the only choice. And customers can choose to move higher up this hierarchy, hand over some of the responsibility of operations to AWS, and really focus more deeply on their business problem. So very briefly, going up that list, above EC2, we have ECS and EKS. These are our container services. Customers would run their own compute infrastructure, but we're handing over the task of container orchestration to AWS. So developers would, within their microservice teams, they'll build containers, they'll register them with the container registry in AWS, and either of these services will deploy those containers across the fleet of compute instances. And we'll take care of scaling them too if you want. Scaling in response to metrics that you might set up, CPU, for example, or even a custom metric. And that's us moving further up the stack, away from the kind of bare metal EC2. Further again, we get to Fargate, which is our serverless container offering. So in Fargate, there's actually no compute infrastructure that you manage. It's all managed by AWS. You hand over that container, and AWS runs it. And then finally, at the very top, we have AWS Lambda. So Lambda is a very popular, very cool service, and it's all about serverless computing. Customers only write code. They never see a server. They never see an IP address. They write code. They hand that code off to AWS, and we run and scale it in response to events. So I've had customers, I had one quite a few years ago, and it was an image sharing application, and the users of the application would upload photos that would be dropped into an S3 bucket, and the deposit of the file in S3 would kick off a Lambda function that would do some additional processing on the image. So that sort of thing is possible. It ends, in the vast majority of cases, it ends up being extremely inexpensive to run Lambda functions as part of your application, and it's a really great, if you have the option of using Lambda, it's a great choice. Another customer more recently had a end-of-month batch process. They had a machine in the data center. It would come alive once a month. It would do some batch processing, and then otherwise would basically sit idle until the next month. That customer was able to take that workload and move it into Lambda, and we're now able to retire a service, retire a server, I should say, and it's costing them fractional cents per month versus the maintenance burden and potential security surface area of that one server. So all of this is to say, as you are thinking, being thoughtfully considering your application portfolio and your applications. You needn't constrain yourself to EC2 and virtual servers. You have other options as well, which can really enhance the productivity of your teams. So if this all sounds good, you might well ask, well, how do we get there? And like Artur and myself alluded at the beginning, we have a large presence in Canada of professionals who are really very keen, to meet with customers and work on projects to help customers get there, to move into these more modern architectures. What I would encourage, though, migrations in general are kind of a scary term. They're often associated with downtime and late nights and pagers going off and that sort of thing. Don't think of it really as a migration or a kind of binary step from old to new. It's better to really treat this as a journey, if you will. Really employing some kind of agile, iterative thinking. Starting with what may be an on-premises monolith. Really start to identify, aspects of functionality that are good candidates for extraction and possibly containerization and running within a containerized environment like ECS or EKS or Fargate. Beyond that, you can even say, okay, with some successful container experiments, why don't we move on to Lambda and use cloud functions and even more lightweight type services. And at every step of the way, we're evaluating quality. Are the users happy? Do they notice? Ideally, if they do notice, it's for positive reasons. Are we happy with the scaling and performance? Are we employing automation at every step so that we're not having to manually copy zip files as part of the deployment process and so on? So really encourage you to treat it as a journey and not a binary step. As part of professional services in AWS, we have a lot of global colleagues, and we've been able to build up a large suite of anecdotes and practice and patterns to really help our customers in this process. So we have a lot of resources that you can take advantage of, and some good methodologies as well. You can think of any kind of major migration or re-architecture process really in 5 phases that we like to say. First, of course, is evaluation. We're looking at the readiness of an organization, the roles that may need to be created, or the upskilling that may need to happen. Then we move on to planning. So a lot of this is portfolio discovery. I've worked with many customers who actually, they've been around from, in some cases, decades, and they actually don't have a good sense of their portfolio of applications, and so they're not ready to talk about whether or not it's a good candidate for microservices, because in some cases they don't have a full visibility into what they're running in their data centers. So portfolio discovery is very important, and I'll touch on some tools that can be used for that process. You want to look at requirements collection, what's new, moving forward into the future, versus the past. Landing zone is a concept that you'll hear. I'm sure there's been some presentations about that today. That is really what is your footprint in AWS look like? What's the security principles, the governance, the guardrails? How do you do identity management? How do you do networking? How does it connect back to your on-prem? Any kind of hybrid type considerations. So landing zone is a topic, on those kind of levels. We have design. So we have many migration patterns. We have concepts like the well-architected framework to help customers really, have confidence that they're operating correctly in the cloud. We have migrations themselves. So we like to help customers plan out their migrations and plan out how they're going to move applications and in what way. And then finally, there's a whole series of work we can do on optimization as well. It's possible to run very efficiently in AWS, especially with some experience and some expertise on your team. You can move workloads to things like Lambda. You can use Lambda charges by the 100 milliseconds, a fractional cents per 100 milliseconds. So for many workloads, you can run amazingly cheaply within Lambda. We have AWS EC2 spot instances, and those are a spot market for reserved compute capacity. With spot instances, you can run up to a 90% discount on the on-demand rate. So there's some really awesome optimizations that the customers take advantage of once they're in AWS. So just on the point of portfolio discovery. There's automated tools in this space that really help you identify not only the entire portfolio, but aspects of the portfolio that are good candidates for migration to microservices. And the output of these tools it can be very interesting. It'll give you, for example, connections between servers that exist in your on-prem environment, and so you can easily identify where the web servers are talking to databases, where the public ingress is happening, isolated islands of functionality that doesn't do much communication and therefore very few dependencies. Those are great candidates in particular for any microservice experimentation. You can see performance metrics, which workloads really have a very demanding CPU or memory type burden, and you can allocate resources accordingly. And then, of course, finally, just the active service naming, being able to identify host names, seeing that in a coherent list that you can then take to stakeholders and help identify owners and identify a plan going forward. Here are some of the tools that you can use for this sort of purpose. We have our own tool, AWS Application Discovery Service, but we have some great partners as well that have some really fantastic tooling in this space. So you'll run their software. Some are agent-based, some are agentless, but ultimately the outcome would be a cost model comparing on-prem to in the cloud, a resource model looking at kind of comparative CPU memory and disk and those kind of fundamental measures versus the equivalent resources in AWS. And then finally an application backlog, just a list of applications and some notion of what's running in the data center and what could be moved into AWS. Now you may have seen this diagram in other sessions. We really tell customers that there's kind of 6 pathways for a given application on-prem. There's a given pathway for it to be moved into AWS and potentially modernized along the way. Everything we've talked about here is really on the blue pathway, which is refactor, and that is really rethinking how an application is delivered. We're using containers, we're using Lambda, we're using some of the other services we haven't even talked about, like our SQS, our native queuing service. But that's in some sense, the most exciting pathway. But you needn't start there. I mean, you needn't start with refactoring an application. There's other options which are perfectly valid, at least to start with. At the top, we have rehost. You can take an application and just move it into EC2. That has the benefit of being very quick and very straightforward. You have like for like. I've had customers who've had a data center closure on the horizon, and so they just simply didn't have the bandwidth and time to containerize their main application. They wanted to get into AWS as quickly as possible, and so they just rehosted from on-prem to AWS. There's another option, re-platform, and that is where you keep an application mostly as is, but you take advantage of some native AWS functionality. So the classic example here would be using an RDS database, which is our managed database offering, using that instead of a database on EC2, but otherwise keeping the application the same. There's repurchase, and that is retiring the delivery of a service that your organization provides and procuring it as a SaaS product from another vendor, either a third party or AWS itself. We have a number of SaaS offerings also. And then, of course, finally, you can retain an application as is and retire. But yeah, as you get that application portfolio, you really want to. These are the 6 options you really want to be considering, and certainly long term, I would definitely encourage at least the consideration of refactoring, because that's when the real efficiencies and economies of scale of the cloud really start to be brought to bear. So this is my last slide, and it's really, consider this a simplified version of the process that Amazon Retail went through in the mid-2000s. Really want to emphasize it was not done all at once. Amazon Retail, even back then, was a very complicated application, and it wasn't feasible just to move that to microservices with many customer transactions and orders and returns and shipments all in flight at the same time. It wasn't feasible to do it at once. But what Amazon Retail did was they really took a very gradual approach and gradually extracted microservices out of that monolith and put them behind an API that the rest of the teams in the organization could talk to. So we started with a single monolith that was handling shipping, orders, inventory, and shopping. And Shipping was extracted into its own microservice behind an API in control of its own data. That was tested, continuous iteration and testing, make sure that works as expected, no impact to customers, no impact to any metrics that we care about. And then we do the next one. The next one to tackle was inventory, and same thing, becomes in control of its own data, exposes its own API, testing all the way, ensuring quality all the way. And then finally, the orders service itself. And this truly is how Amazon now operates internally. It took a long time to get here. And AWS didn't exist when this process began, so it's much easier these days than it was back then. But we've learned a lot of lessons along the way. We're more than happy to talk to customers anytime and offer expertise and see if there's some ways that we can help you all. So thanks very much for your attention. And like I said, please come and talk to us. We'd love to chat anytime, and we'd love to hear the challenges that you're facing in your organization and any ideas you may have. Thank you.